Okay guys, welcome to today's class. In today's class, we'll be considering quotient rule of differentiation. And please, if you haven't subscribed to this channel, kindly do well to subscribe to this channel so you get notifications when I upload new videos. Alright, let's talk about quotient rule of differentiation. If you are given a function y equal to u over v, where u and v are functions of x, then to find the y dx, we need to apply the quotient rule. And what is the quotient rule? That dy dx is equal to v du dx minus u dv dx all over v squared. This is a very simple rule. Whenever you see a function having a division of functions, a numerator and a denominator, simply call the numerator u and call the denominator v, and then apply the quotient rule. Quotient rule says, hold your v, differentiate your u with respect to x, and then a minus, you must take note of the minus in between, it's not a plus, and then you hold your u, differentiate your v with respect to x, and then divide through by v squared. Do not forget to divide through by v squared. Alright, now let's see some practical examples that can help us understand quotient rule better. Let's look at this example. We have here y equal to x plus 1 divided by x plus 2. Now if you look at this example, you clearly see that there's a division of functions here. We have a numerator and a denominator, and so we need to apply our quotient rule. The first thing is to identify your u and identify your v and differentiate them, and then apply your quotient rule. So let's tackle this problem. We have our u, our numerator, to be x plus 1, and then also identify your v, x plus 2. Okay, the next step is now to differentiate u and v. So differentiate u with respect to x. Now, remember how to differentiate algebraic functions. If you differentiate x is 1, and when you differentiate a constant term, is equal to 0, right? And next, we find our dv dx. When you differentiate x here is 1, and when you differentiate 2 is 0. Alright, so we've gotten our du dx and our dv dx. The next thing we just need to do is to apply our quotient rule. Alright, we follow strictly on our quotient rule, and then we have that dy dx is equal to, now look at the quotient rule. It said v, we hold our v first and then write du dx. What's our v here? V is x plus 2, and then du dx is 1. Alright, that's good. And then we have a minus here, and then we have u, we write our u, x plus 1, and then dv dx. We are following strictly the quotient rule. dv dx is also 1. Okay, and do not forget v squared down here. We said divide through by v squared. V squared here is x plus 2 squared. The next thing is to simplify this expression. And to simplify this, x plus 2 times 1 is equal to x plus 2. X plus 2 times 1 is still x plus 2. And then x plus 1 times 1 is still x plus 1, right? But we need to distribute this minus into x plus 1. Right, minus into x is a negative x, minus into 1 is a negative 1. Alright, divide through by x plus 2 squared. If you want, you can expand the denominator too, but if you don't want, you can still keep it in this form. But let's expand this. To expand any binomial of degree 2, you have a binomial expression of degree 2. What you simply need to do is to say x raised to power 2 is x squared, and then 2 times x times 2 is 4x, and then 2 squared is 4. It's a very simple way of expanding binomial when the power is 2. x raised to the power 2 x squared plus 2 times x times 2 plus 2 squared. All right, and we have this. If we go further to simplify, x minus x is 0, and then 2 minus 1 is 1, all over x squared plus 4x plus 4. And this is our dy dx. Let's also look at this example. Y equal to tan x. Alright, and from this example, we'll see how to differentiate trigonometric functions, right? Now, whenever you see a trigonometric function and you are asked to differentiate this function, the first thing that should come to your mind is to simplify this function to its basic trig values. You need to observe if this function is in its basic trig form. And when I mean the basic trig values, I mean sine x and cos x. Alright, so whenever you see any function, the first thing you do is to observe if it is in its basic form. If it is not in its basic form, reduce it to the basic form, and then you can now see the rule to apply. Alright, now the question now is, what is tan x in its basic form? Tan x is the same thing as sine x over cos x, right? Sine x over cos x. Now, it's in its basic form now. And from this, we can now see the rule to apply. Because this function is divided, I will apply quotient rule. When this function is divided, you apply quotient rule. I simply need to identify my u and my v. The numerator is always my u, denominator is always my v. So, I'll write u equal to sine x, and my v is cos x, right? Okay, this is the basic step. The next thing is to differentiate u and v. If I differentiate u with respect to x, if I differentiate sine x is cos x. I need to differentiate my v with respect to x. Whenever I differentiate cos x, it's a negative sine x. Right, I've gotten my du dx and my dv dx. The next thing is simply to apply my quotient rule. And look at my quotient rule here. I simply need to follow this rule strictly. That means my dy dx would be v du dx. V here is cos x, and then du dx is also cos x. Alright, and then in minus here, u dv dx. My u here is sine x, and then dv dx is a negative sine x. And then divide through by v squared, all over v squared. V squared is cos x all squared. Next thing is to simplify this expression here. So cos x times cos x, we know this to be cos squared x. Alright? And then a minus minus is a plus. And then sine x times sine x is a sine squared x. All over cos x raised to the power 2 is cos squared x. Now, there's an important trig identity that says that cos squared x plus sine squared x is equal to 1. So this gives us 1 here on the numerator. And then we have cos squared x. Now, 1 over cos x as we know is sec x, right? Now, that means 1 over cos squared x will be sec squared x. Remember, 1 over cos x, 1 upon cos x is equal to sec x, right? So 1 upon cos squared x, 1 upon cos squared x will be sec squared x. Alright, and so this will give us sec squared x. Alright, and this will be our dy dx. Now, pay attention to this. It is important to note that when you want to differentiate a trig function, you need to first of all simplify to the basic trig values, the sine and the cosine. It is also important that while simplifying your dy dx, you make sure as much as possible reduce this expression to its compound name. This is still basic form, right? But 1 over cos gives a different name. As much as possible, reduce this to its compound name and not the basic trig values. Let's look at more examples to better understand what I just said. Let's look at this example, y equal to cos x. Like I said in the last example, whenever you are given a trig function and you want to find dy dx, the first thing you do is to simplify this trig function to its basic forms. And we know that cos x is cos x over sine x, right? So we need to first of all split it to the basic form, cos x over sine x. So we don't just differentiate directly from here. We split to the basic forms. From here, we can now see the rule to apply. We can clearly see that this should go with quotient rule, right? Now, we need to identify our u. Our u is cos x. And then our v is sine x, right? The next thing is to differentiate u and also differentiate v. If we differentiate u here with respect to x, if I differentiate cos x, it's a negative sine x, right? And then I'll need to differentiate v with respect to x. If I differentiate sine x, is cos x. And right after this is to apply our rule, quotient rule. We have our rule here, we follow it strictly. dy dx will now be v du dx. v du dx. Our v here is sine x, and then our du dx is a negative sine x. Alright, and then there's a minus here, then u dv dx. U is cos x, and then dv dx is cos x. All over v squared. All over v squared, v is sine x or squared, right? We need to simplify this further. We need to simplify this. So if we simplify this, sine x times negative sine x will give us a negative sine squared x. And then we have a negative here. Cos x times cos x is cos squared x. All over sine x all squared is sine squared x. From here, we can see that minus is common. We can factor out minus, and then we have sine squared x plus cos squared x. I factored out the minus, so we have this, right? All over sine squared x. And this will give us a negative. Remember that sine squared x plus cos squared x is 1. So we have 1 upon sine squared x. Okay. Now, like I said earlier in the last example, we need to, as much as possible, while differentiating trig function, as much as possible, do not keep your final answer in the basic trig value. Alright? Sine is a basic trig value. As much as possible, rename it to its compound name. And we know that 1 over sine x is cosec x, right? So 1 over sine squared x will be cosec squared x. But remember, there's a negative sign first. So this will give us a negative cosec squared x. And this is our dy dx. Let's also look at this example, y equal to cosec x. Like I said, we need to simplify this. We need to split this to its basic form. And cosec x means 1 over sine x, right? It simply means that our u is 1, our v is sine x. We need to find du dx. If I differentiate 1, I will have 0 because it's a constant value, right? And then I find my dv dx. If I differentiate sine x is cos x. I've gotten my du dx, I've gotten my dv dx. I can now apply my quotient rule. And what's my quotient rule? That dy dx is v du dx. V is sine x, and then my du dx is 0. I'm following it strictly. Whatever value I have here is what I will impute here. So minus, and then I have a u is 1, and then dv dx is cos x. all over v squared. V squared is sine x all squared. Alright, and then I'll keep on simplifying this. Sine x times 0 is 0. And then minus 1 times cos x is cos x, yeah? So, and then sine x raised to power 2 is sine squared x. This will give me negative cos x over sine squared x. Alright, but like I said, pay attention to this. It is important we try as much as possible not to keep our dy dx, our final answer, in its basic forms. Alright, and so how do we convert this to its compound forms? What we simply do here is we have a negative cos x over sine squared x. We can say this as a negative 1 over sine x and then cos x over sine x. Okay, we can split this to be this, right? Because this is negative cos x over sine squared x. Negative 1 times cos x is still negative cos x. Sine x times sine x is still sine squared x. So we can write this here. We can write negative 1 over sine x times cos x over sine x. From here, we can now see that 1 over sine x is cosec x, right? So we have a negative cosec x. 1 over sine x, cosec x. Then cos x over sine x is cot x. And this will give us our dy dx. Negative cosec x, cot x. Let's also look at this example to better understand how to differentiate trigonometric functions, right? Now we have y equal to sec x. And like I said, we need to split this to the basic form. And this will give us sec x is 1 over cos x. You must split it down to the basic trig values before you can proceed to find your dy dx. And from here we can see that we need to apply quotient rule because we have a numerator and a denominator. Our u will be equal to 1. Our v will be cos x. From here we can find our du dx and our dv dx. This will give us 0. dv dx will give us a negative sine x, right? We've gotten the u dx and the v dx. Next thing is to find dy dx. So we find our dy dx by applying quotient rule. V du dx. Our v here is cos x, and then our du dx is 0. Negative u here is 1. Then dv dx is a negative sine x all over v squared. That's cos x all squared. Alright? To simplify this, cos x times 0 is 0. Minus times minus is a plus. 1 times sine x is a sine x here. All over cos squared x. This will give us sine x over cos squared x. We need to simplify this. We need to remove this from the basic trig values to its compound name. And this simply means we can write sine x over cos squared x as 1 upon cos x, split them, and then this becomes sine x over the next cos x. Right. Okay, so this will give us 1 upon cos x times sine x upon cos x. 1 upon cos x is sec x. And sine x upon cos x is tan x. So this will give us sec x tan x. This is the derivative of sec x. Now let's see if we can differentiate functions involving quotient rule without directly looking at the rule. Let's look at y equal to ln x all over exponential x. Let's differentiate this without looking at this rule. Alright? Now, we said to find dy dx, first you need to identify the rule to apply, right? And because this is division of functions, we need to apply quotient rule. And to find dy dx directly here, quotient rule says v du dx. You start from your v, then differentiate your u minus u dv dx all over v squared. So you hold your denominator, your v, I'll hold my v, then differentiate my u, right? If I differentiate ln x, I have 1 upon x. Remember, the derivative of ln x is 1 upon x. V du dx. And then minus, then u dv dx. I will now hold my u. If I hold my u is ln x, then differentiate the denominator. If I differentiate exponential x, I will still have exponential x. V du dx, hold the denominator, differentiate the numerator, minus hold the numerator, differentiate the denominator. Alright, then all over v squared. V here is exponential x, all squared. And then the next thing is to simplify. From here we have exponential x times 1 is exponential x all over x, right? Then we have a negative ln x exponential x all over exponential x raised to power 2, power law of indices, right? This multiplies, so we have exponential 2x. We can further factor out common terms. If you keep your answer here, you are right. If I factor out common terms, I will have exponential x into 1 upon x minus ln x all over exponential 2x, right? I can further simplify this if I want to give me exponential x divided by exponential 2x will give me 1 upon exponential x, because 1 over exponential x will clear 1 from here, right? So we have 1 upon exponential x, and then we have 1 upon x minus ln x. We can keep our answer here, and that will give us our dy dx. Okay, to summarize the idea of trig functions, simply know that the basic trig functions are sine x and cos x. Although at some point we could also say tan x, but I want to keep it as sine x and cos x. And then from here, we can build up other trig functions. Know that tan x is equal to sine x over cos x, right? You should know this. Tan x is sine x over cos x. Also know that cos x is cos x over sine x. The next you should know is that cosec x is 1 over sine x. This is cosec x. You should also know that sec x is 1 over cos x. Also note this very important trig identity, that sine squared x plus cos squared x is equal to 1. It is still the same thing as cos squared x plus sine squared x. And then also note that sec squared x is equal to 1 plus tan squared x. These are important points you should know in trigonometry. In the next video, we'll be discussing chain rule. We'll see how to differentiate chain functions. Kindly subscribe to this channel if you haven't subscribed already.